so I know I've got this cool tool here for clamping together 3-inch pipe and being able to do, you know, butt weld like this and have it be a third hand that holds things together while I put on a couple of tack welds, right? We know we've got this tool, which basically has these little triangular shaped guys which pull the tube in and then want to hug it against this. This is like hugging against your chest, okay? Right there, okay? I'm thinking about buying a big one of these guys and making something more buff out of steel that, you know, I'd saw off these jaws and put like these. Look what I found. Circular 3-inch rings that I used for this exhaust that I made for a Corvette. Proof positive, by the way, that, let me zoom in here, use the proper lens. Once you do a bend like this, it's never exactly round. It's kind of caved in the center here. So that begs the question of whether you really want to bother to make something that's perfectly round like this. But I was thinking of like cutting like a third of a circle off here, and then a third of a circle off here, and then when it grabs, it actually grabs it in a, you know, like a little bit here, that kind of thing. And it's pretty positive. It's a lot of work. Don't know if I want to do it or not. All right, so I bought one of these things, and I'm trying to figure out how to maybe do something similar to this, where you have a mechanism that squeezes the tube down and against this part. In this case, it would be this way. Squeezes it down and this way. Squeezes it down and this way. I'm looking at using 2 rings like this. Basically, this is how wide they have to be, so it'll straddle the actual, you know, crack between the 2 pieces of tubing. And there wouldn't be an entire circle, of course. What I would do is I'd probably cut off a little piece here to here, and then here to here, and I'd have extra pieces. And the guy down here would probably be only about this big. But I need a piece of metal that goes from here to there. And I could probably get it by cutting these guys off, and I'll have some spare metal. So if I'm gonna do this, I mean, just dive in. I would basically just draw a line across the inside edge here to give myself enough material to weld with. Or maybe if I need a little bit of extra material, I could cut halfway through and weld on the outside and have some support and just go for it. See what I get. Okay, there's no turning back now, so I'm talking through a ventilator mask. Basically, what I've done is weld one circle onto here, and it's perfectly registered as a circle, of course, because it's still a circle. And what I'm going to do is put a tube in there, clamp the other side on, and then the tube will act as registration to make sure that this side and the other side circles are perfectly centric with each other. Then when I'm done welding it all up, I'm literally going to come in with a hacksaw, actually a power hacksaw, and start cutting where I want and just leave the feet where I want them to be. But this is the only way I could think of if I'm going to do a fixed, because this is a fixed system. These feet are not going to swivel. And make sure that it's absolutely circular. God help me, I did it. Don't make fun of my welds. I'm not a good welder. But I get stuff done and I try things. So don't make fun of my welds. But point is that it's straight with the piece of tubing, right? Okay, it's pretty cooled off. Time to take the old tube out. It shouldn't fit super snug, but it should fit right in there. I gotta get these clamps off and figure out how to free this thing up. It's basically useless right now. Actually, it's still pretty warm. So yeah, I gotta cut here and here, basically make these so that they're not, there's a decent enough hole that if I open it up, I can fit 3 inches in there. And then you want to basically get from like the midpoint open so that it pushes down, because if you give it any support from underneath, then it's going to hold it upwards. You know what I'm saying? So in fact, I probably want to slice across like that a little bit in order to bias this so that it's, as it squeezes it, pushes it down towards this basically your chest. You know, like if you're grabbing something and hugging it in, this is your chest. So that's the chest part. That's the part we want to have everything head towards. And if there's any curve going this way on this piece, it's going to hold it outwards this way rather than push it downwards. So it clamps stuff. You can literally take it and come up to a 3-inch pipe and go clampola, and it clamps right there, and it pushes it down into the bottom part, which is what I wanted. Now let's try using it on 2 small pieces of curved material to see how it does. See if it actually lives up to its its expectations here. It's kind of dirty still, a lot of sharp, nasty, jagged edges on it still. I could clean it up, but I want to make sure it's worth spending any time on. God, this thing is heavy. Honestly, I would love to literally get a big old drill, a drill right through here, and take off some weight, and then just literally go at this whole thing with an angle grinder just to reduce some weight because it weighs so much. Probably close to 2.5 pounds. Okay, you guys have been patient. This is probably cutting off my head. I really don't care. I'm going to show you. Look at this thing. I mean, it weighs like 2 pounds. All right. I'm going to show you first clamping from a straight piece onto a curved piece. Let's see how we do here. I haven't even tried a straight piece to a straight piece. That would be a nice test, but it'll probably do that. So, lining these guys up. That's clamped. I didn't quite get the entire. You have to aim it. It's a little harder to aim than the other one because it's so narrow. And the little circular things have to be on both sides of the metal, if that makes sense. It's clamped. Is it aligned? Yes, I can see the line in between each one of these guys. Whoa, holy shit. It works. All right, when I moved it a little bit, I did lose some registration right there, but man, it holds it in alignment really well as far as like unwanted seams and edges. All right. It is good enough for the work of the government. It'll do the thing it's supposed to do. Bzzzt, bzzzt, bzzzt. Remember how I wanted my 3 spot welds? Well, I get them. So this is awesome. This seems to work. Now we're going to try 2 curved pieces. See how we do. So 2 curved pieces. See, 1 curved piece, 2 curved pieces. And not even like, you know, following their own curve like they already, we're going to do a compound curve, you know, something really messed up. Because McLarens, they do not have much room back there for the exhaust system. Here we go. Holding it still, lining up my lines here. I can't see the other side, so I'm just kind of guessing. As I'm clamping it, I can see it moving things around. Oh, I see, because I'm not on the seam on that side. It's hard to feel. You know what I'm gonna probably have to do? Loosen it up just a little bit. Give it the benefit of the doubt. So this doesn't have as much give as the one with the plastic feet, you know, because this is all metal. And it's hard to hit the line, I will tell you the honest truth. Because you do have to be more exacting. Well, this right now, the way I've got it, there's a huge gap right here, and it's pushing it in. Although it is pushing everything back in this direction. So the problem is I'm using 18 gauge steel, which is also very flexible, and it collapses pretty easily. So let's do even less. Back it off a little. See what we get. Yeah. That's actually very nice, but it's not held very tight. And there is a decent gap here. The God's honest truth, and this is a bit disappointing, I will tell you this, is you could use it, but this works pretty much as well. And the nice thing about this one is it's more forgiving because it's rubber. And I thought that this would force things to conform, you know, so that circles would line right up. And what it's doing is it's finding the weak part of the metal and flexing it and making it so the 2 pieces don't meet as well as they possibly could. Let me just clock it around a little bit and see what I get if I go over here. Before I stopped working on this particular project for tonight, I started to think, why does this feel better than this? Like, feel better than this does? And it's because you got metal sliding against metal. So I actually just took some, I happen to have red duct tape, and just put 2 layers on each one of the surfaces. Now remember, you don't need to have the crack in between the steel because we're not going to weld there. We're welding here, here, and here. So it's okay if it's a continuous foot. Does that make sense? So let's give it a try and see how it works over there on the stand. So I'm going to try the red tape on this and see if it's better. The other thing you have to remember is when you're using a piece like this and you put it in a vise, here and you squeeze down here, it's going to distort the heck out of it. So I'm kind of trying to grab it more from the middle of the vise here. So let's see how it is with the tape. Clunk it on there. See if you can find the center right there. And give it a clamp. It looks like it's straddling the cracks. I'll tell you one thing, right off the bat, it just feels more positive, kind of like the way the plastic and rubber one does, because you don't have this sort of metal against metal sort of slidey feeling, you know, when you clamp it down. This is a really good clamp I've got going here. In fact, I could loosen it up. This is kind of nice because you can modulate like this. Give it a little thumb screw and squeeze even harder if you wanted to. And it didn't move a thing. And the edges look real good. Now let's try our difficult compound curve, where we're kind of doing a sideways thing off like this, and see if we can find where it likes to be squeezed the most. Got it going here, here, and here. That looks like it's going over the edge on all of it. It did? Wow, that was super easy. And all the edges look really, really nice. So, and again, if I want to modulate it, sorry, I know I'm out of frame here, I can open it up a bit and literally tighten it down and give it a squeeze. Just give it a squeeze. And yeah, this is actually working out 10 times better. What happens is that the metal doesn't walk like against the metal because the tape is holding it still. So I could use tape. I could maybe try and experiment with like Plastidip or something fancy like that. Maybe find some sort of high temperature silicone tape. That'd be awesome. I don't even know if people make that. Right now, this is just red duct tape. So cool, much improved. I'm actually feeling better about this tool now.